is our next test. Please notice that we have this test, 2 more tomorrow, and then our quiz is Friday. All right? So, alternating series test. Please write it down, and then we will talk about what it all means. How do you recognize if it's alternating? Okay, positive, negative, positive, negative. How about within the series, what usually jumps out at you? Okay, -1 to the n, -1 to the n plus 1. Grayson, did you forget your glasses?
Oh, I got some for you. They won't help.
Okay. Code word, wear your glasses.
Yep, you're wearing glasses.
Okay, so we recognize that it's alternating because of that -1 to an n, -1 to an n plus 1 power. And what this is saying is it's going to converge if both the limit of the sequence is 0, which we check for anyway, and what does that second part mean? Decreasing. And I think I taught you 3 different ways for you to test whether a sequence is decreasing. Do you remember? I said this will come back to help us. Yep. Alex, well, what did you say? Difference. Okay, some difference. They go hand in hand, right? So you can take the difference and see how it compares to 0. You can take the ratio, see how it compares to 1, or you can take the derivative of what the function would be and see if it's negative. Okay, you have 3 options. I know you're probably most comfortable with the third option that I just discussed, but you can use any of the 3 options. So you need to show me, if it's an alternating series, that the limit is 0 of the sequence and the sequence is decreasing. If you show both of those, then you can say converges by the alternating series test. Okay, so without singing it, please write this down. I'm looking right at you, buddy. Every time I say write this down.
I thought you were talking about another great song.
Okay. So I'm going to flash back here. When I say a sub n, does a sub n include the -1 piece? No. What we need to show is the piece that is not alternating. We need to show that the limit is 0 and it is decreasing. So, first of all, we need to look at the limit as n approaches infinity of 1 over n. What is it? 0. Woohoo! Okay. Second, we need to show that this a sub n 1 over n. We need to show that it's decreasing. How would you like to do that today?
Derivative.
Derivative test?
Yeah.
What did you say?
Difference.
Difference test? Or ratio test? We're going to go ahead with derivative is probably the easiest for this one. Derivative is negative 1 over n squared, which is always less than 0. Therefore, we say this converges by the alternating series test. Anyone bothered by the fact that this one converges? Okay. We will come back to this example and talk more about it converting.
Are you saying like since it's just bouncing up and down, but it's getting closer like that? That makes sense.
Okay. All right. Next one. Please put it on your paper. What's our a sub n?
1 over the square root of it.
And the limit towards 0 would be? I mean, the limit towards infinity?
Yeah. And or ways to push up 0 is the limit.
Okay. What would you like to use to test for?
Derivative.
Okay. Now I need to get my sentence out before you tell me. All right, and that would be negative 1 over 2 n to the 3/2, which is always less than 0.
Yes, it is.
Therefore, it converges based on the alternating series test. Okay. Isn't this test nice? Like, you don't really have to think too far out of the box for any of these, right? It's pretty cut and dry. Is it alternating? Check these two things. Okay? All right, next one. Okay. First, we check the limit towards infinity. We really have to write this down, showing the limit. We should be doing it in our heads with any other problem so that we don't waste time if the limit is not 0. But for the alternating series test, you do have to write it down and show me that the limit is 0. Is that the case?
Yeah.
Okay. What's going to be interesting is how we determine whether this is decreasing. Is the derivative test going to work? No.
How
Difference or ratio?
I think ratio as well.
I think ratio would be the best. So we need to look at the n plus 1 term divided by the n term. which would turn out to be n factorial over n plus 1 factorial. How do we simplify
Just a quick announcement from the activities office about the week's activities. Girls basketball at Omaha Central and wrestling at Omaha Bryant have been canceled for tonight. All other after evening practices are on as scheduled unless you hear differently from your individual coach or sponsor. Sorry about the interruption.
Oh, yeah. Well, snow is going to stop swimming practice. All right. How are we going to reduce this? N plus 1 times n factorial is the same. So those cancel, and we have 1 over n plus 1, which is always less than 1 if we're talking about positive integers for n. What does that prove? It proves it's decreasing. If the term before it divided by so if we're talking about the term after divided by the term, if that is less than 1, that's got to mean our terms are getting smaller, right? So this is going to converge by the alternating series test. Well, we're not going to have to use trig to do anything. But let's think about it here, people. Cosine of pi, cosine of 2 pi, cosine of 3 pi, cosine of 4 pi, cosine of 5 pi. What are those values? 1, negative 1, 1, negative 1, 1, negative 1. So this is what we have, right? Can I rewrite it to that? Yeah.
Yeah.
Okay. What would our a sub n be? What? And what's the limit as n approaches infinity? So this diverges because of the nth term test. It failed the nth term test, so we can't even keep going to see it.
Doesn't it converge to 0?
What?
I don't know.
No, because you're bouncing back and forth between 1, negative 1, 1, negative 1. So an nth partial sum would either be 0 or 1. Like there's no like getting closer to a number as you keep going. You see what I mean? It just,
The limit of 1.
yes.
It's just 1. It's just on a straight line.
Because we have to take the limit of a sub n. There's really like nothing attached to the negative 1 piece. We just say like we're multiplying by 1, and so that's our a sub n. Right over here, we took whatever was in front, whatever was with the negative 1 piece. That's what we looked at the limit, right? Well, since there was nothing there, it's just 1. Okay. Now we are going to talk about being conditionally convergent versus being absolutely convergent. Have a quick conversation with your neighbor about what you think that means. Have a quick conversation with your neighbor about what you think that means.
Absolute convergence means that the relation is conditional.
saying conditional means that it has to be just infinity, but
We're not gonna do,
it's always equals. When it's greater than.
yeah, we are.
This one conditionally converges.
Ooh. Oh, like the thing I was talking about? Oh, like bouncing up and down.
Not too. Okay, what if we took away the negative 1 to the n plus 1? What would we have? We would have 1 over n. Would 1 over n converge? No, but if we put the negative 1 to the n plus 1 power with it, it does converge. You see what I mean?
Yeah.
Okay, so we have some alternating series that converge. We say that if you take away that negative 1 piece, if it still converges, we call it absolutely convergent. If you take away the negative 1 piece and it diverges, then we call it conditionally convergent, because it's only converging because of the alternating piece. So what we're going to do in these next two examples is determine A, whether the series converges or not, and then B, does it converge absolutely or conditionally. So here's our first example. We recognize that it's an alternating series because of the negative 1 to the n plus 1 power. Okay. So first we need to look at the limit as n approaches infinity of the non-alternating piece, 1 over n plus 1, the quantity squared, which is 0. Good. Next, we need to make sure it's decreasing. So if we take the derivative, we have negative 2 over n plus 1 cubed, which is always less than 0, so we are decreasing. Right now we know that it converges based on the alternating series test. Okay. Now, if we are going to determine absolute convergence, we need to take a look at the series from n equals 1 to infinity of 1 over n plus 1, the quantity squared. What are your suggestions for proving that to be convergent or divergent?
N squared.
You wanna compare it to 1 over n squared? Okay, so we could compare to to the series of 1 over n squared, a convergent p-series. And are we doing direct or limit? Can't we do direct? Is 1 over n plus 1 squared always going to be smaller than 1 over n squared? Okay. So, since that is the fact, then 1 over n plus 1 squared converges based on the direct comparison test. Okay. Which means we know that the series from 1 to infinity of negative 1 to the blah, 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 absolutely converges. We know that because A, it converges, okay? B, we took away the alternating piece and it still converges. So it absolutely converges. We can put absolute values on that sucker and it's still going to be a convergent series. Maybe time to sit down. That is baloney. You just said 13 minutes. Here.
13 more minutes of enjoying the Eagles. 13 more minutes of enjoying the That's it.
Okay, let's get through this and then we can talk about our favorite commercials from last night.
Before we do that, can we talk about how we feel about the game last night?
Yeah.
Well, but after notes.
Because
Oh, the snow. I was like, I'm gonna let you leave when the bell rings.
no, like just because I don't think I'm gonna drive the way that I
Really fast.
today.
Okay, so let's see if this A converges. So the limit as n approaches infinity of 1 over radical n. Perfect. How would you like to, did we already do this?
Yes.
I was gonna say, I think we've already done this. Okay. So we already know that this converges based on the alternating series test because we already did it. Now, what do we know about this guy? Diverges based on which test? Okay. So this converges conditionally. You okay?
I'll be good for 10 more minutes.
Okay. All right. Last topic. We are talking about infinite series, yes?
Yeah.
And we're testing their convergence, but we're never, I should not say never, we're rarely actually finding what their infinite sum is. Agreed?
Yeah.
Okay. We are able to tell, however, the error in our calculation for an nth term sum versus what our infinite sum would be. Please write this down. Write this down up here. Yeah, the top part would be good. Whether you want the asterisk, the double asterisk or not is up to you. That's just explaining what it means. And I'll talk through it, but just write it down first so when we talk about it, you have it. Okay. S stands for what? Sum. Which sum? Which sum? The infinite sum. Which is what the sigma is telling you. Okay. S sub n stands for which sum? Okay, the nth sum. So it could be like the 6th partial sum or the 10th partial sum. Okay. That remainder, so whatever this R right here, that's telling you like the most amount of error we could have. And that number is less than or equal to the next term in the sequence. So basically, the error in calculating the infinite sum, if you found the 5th partial sum, then its error in calculating or approximating the infinite sum is less than or equal to the 6th term.
Not 6, the 6.
Yes. We are going to approximate the sum of this guy using S sub 6. So like this equals a sum that we don't know. It is converging to a sum. The 6th partial term would be 1 over 1 minus 1 over 2 plus 1 over 6 minus 1 over 24. Are you agreeing with me? Plus 1 over 60 minus 1 over 120. Which is the following number. Okay. Not yet. 7 factorial is 720, correct? So this is the 6th partial sum. The next term would be 1 over 7 factorial, which yes is 1 over 720, which is 0.0002.
So it's 1 times 2 times 3 times 4 times 5. So wouldn't 1 over 60 be 120? And then that would be.
Oh, was I? I see. Sorry, Grace. This is 120, 720, and this one is 7 factorial. Foolish, right? Okay. So what this says is that our sum, when we use the 6th partial sum to calculate it, it's off by at most 0.002.
That's not bad.
Thank you, 0.002. So the sum is in between the 6th partial sum plus the 7th term and the 6th partial sum minus the 7th term. This reminds you of staff?
Except I don't, this difference is consistent.
This isn't what?
Well, like normal. We make it.
Okay. This is we're almost there. Tomorrow, we're going to talk about the ratio and root test. Ratio test, one of my favorites. Root test, very easy. And then we're going to spend a couple days working on when we put them all together, how do you know when to use what? Okay? All right.